you are totally new towards the world of an AI, so I decided to work with a different things with you before. Then I'm going to put you with an agent because if you already knew 1% that we had studied, 1% that we had studied before, then this will gonna help you to get an opportunity into the market. Because what I told you about the different stuff in the game, in the Python, that will gonna help you to clear your interview, to clear your things. Even if you write a simple thing that you know how to build your own algos, how to build your own logic, how to build your own logic. If you're gonna put this statement, how are you gonna build your own logic that you knew that you can make your own logic? And with the help of this today code, you can make it, memorize it, you can go through it with me with it again and again. How many times you need revision, I will gonna help you down in it. But in today's session, what we were gonna do, we were gonna make an agent that is going to be like a reflex agent. So we are going to make a Pacman game, which we used to play while in the childhood. So with the help of this game, I'm going to tell you about how AI will gonna help you with this reflex agent. Now, in today's lecture, what we have 2 or 3 things that we need to discuss. That is, first, receives an act and has a goal. That's it. We are not going to do anything else. We are not going to put hard AI in today's session. So we are just going to code a simple AI like this way, the simplest AI we are going to make in today's session. Agent. Who are the agents? What they will do? What are their roles and how they're gonna play with us in the world of AI? Agents are the space that contain some data. Now, what kind of data do agents got? What kind of data? The data that we will gonna create. So there are 4 types of agents, 4 different types of agents. First, fully observable, single agent, and deterministic with the help of static and discrete. But static, we will gonna count, but not discrete. Discrete agents are obsolete from like since I guess 2011, if I'm not wrong. So discrete agents was obsolete since 2011. So we're gonna have full observable, single agent, deterministic, and static. What are they? How they work? How they're gonna do the things that we need to? So I'm going to let you know with the help of this example we got today. Now, we all played this game. We all played the game like this way, the Pacman. So Pacman is need to eat all the white dots in this specific box, Now, what I'm going to put the stress on this specific box. This specific box, this red blue box is the environment that the agent got. Environment, the box in which we have our agent.
Dr. Saab, sorry to interrupt. Can you add the Madam Fatima?
Sir, I don't even get the notification from her right now.
She said she already added.
No, it's nothing on my participant list.
Nothing there? Okay, I can ask her to rejoin again. Thank you.
Sure, sir. Most welcome. Okay, now the box is the outside and what inside. So inside we are going to have that achieve things, the achievement of the goal of the specific one. Now, let's start creating it with the simple code. Okay, welcome Ms. Fatma today. Okay, now I'm going to let you know about all these things once again. Then we are going to start coding what we shall gonna do in today's session. And in today's session, we are going to do the simple thing, the simplest one, through which even you can memorize all the code. You can get the opportunity in all over the world in no time, because today we are going to discuss about the most important part of an AI, um, as well as I can say the easiest part of an AI, that is agents. Agents are called actually the spaces. Simple words. I'm going to use simple word today, spaces. Agents are the spaces that we need to calculate, that we need to count. That's all. So agent means the space that we need to calculate. Okay, now in this part of the game, these are the spaces, the white dots are all spaces, and this Pacman is our agent. Now this agent needs to eat all the white dots that is in the box, that's in the box, that's the world, and agent need to eat all of the boxes, white dots actually. Now, okay, let's make it code with PyCharm. So today we are going to do the easiest lecture, one of the easiest lecture. The easiest, why? Because it's going to be like in a baby steps. It's, to be honest, it's going to be like in a very baby steps. Like how we gonna code, how we gonna make environment, how we gonna make agent in the specific environment. So this is how we're gonna make a code over the PyCharm, and it's going to be like the easiest thing that I have ever done in my life while decoding. So I'm going to make this game with the help of an AI. So let's make it happen. So I'm going to say this is going to be like Pacman. We used to see the example of it. Okay, let's create it. So what you need to work on, so just follow the steps and you will get everything that you need to do in the field of an AI. So let's start working with this specific environment, the Python. So before it's going to start, I'm going to let you know what things that you need to install, what libraries that you need to do, that you need to use for this part of the code. The simple one that you can easily download from this interface as well. Okay, now this is the project. This is our project, the Pacman. So I'm going to make a file of PCman. It's going to be like the Pacman, because we can choose the same name for our file as well. If we're gonna choose the same name, like if I'm going to say the Pacman, it will gonna happen in the same way. But while executing the code, it will gonna create a little bit conflict. So I'm going to let you know how if you will find the conflict in that file as well, then how you're gonna make it solve in just seconds. Okay, let's make the reflex agent in AI, the Pacman, the goal based. Actually, we have the goal that this Pacman need to eat all the dots before it will be catched by any ghost. So our agent will gonna plan ahead. So we plan already that this Pacman needs to eat all the white dots before it will be caught by the ghost. Okay, so what we need to do. Okay, I'm going to put my oldest compiler. Okay, you guys already have that same compiler as I have. Okay, so on this terminal, just click on the terminal. You need to do pip install py game, that will gonna help you to design a different game, because I'm going to put some of the libraries from py game. Like I'm going to import random choices, then turtle, and then the fourth one is going to be like floor and path. Floor that I'm going to make, that I already have certified environments. And the second file I need to make it work with is the console file. So I'm going to make it clear for a while. Okay, now pip install the console file. It's free games. This will gonna provide me a different things like in the way if I'm going to say like the environment that I need to create, the background, the interfaces, and the things that I need to do. Okay, now let's start with the code, the coding environment. So from now I need random choices of my dots. Random import choice, choice. See, it's gonna happen with the simplest way that you're gonna have everything. Now from turtle, TURTLE, from the turtle, import all the files, all. When I'm going to put star, when you don't even know what file you need to find, what file you need to create, so just put star. This will gonna help to find every file that you need to do. Okay, now from free games, what I need floor, yes, and what I need a vector. Vector means that Pacman. Now this is my vector, this is my vector, that Pacman. So I'm going to do a planning right now. So I'm going to make a plan in which I need to eat all the dots from 0 to the toppest score. Now I'm going to planning ahead. So I'm going to make a decision. So for that part, I'm going to say state is equals to, so I'm going to plan ahead. As I told you, we are going to plan ahead. State equals to brackets. Now, how many things, what the things we need to count? It's score, colon, starts from 0. Now, it will start counting of zeros at the back end, path, because the reflex agent always cover the complete path, the path in which our Pacman will gonna walk. Okay, now the path. Path of this we are going to calculate from the turtle, 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 and the path will be visible. Yes, it's going to be like, right now it's false because we don't have dots right now over this path. And writer, so we need to write, we need a writer. Why? Because my turtle needs to find the ghost as well. So visible of those ghosts are gonna be false right now because we don't have one. Now aim, the goal. Our goal is, so I'm going to put it as a goal. So our goal is to finish that dots and save yourself from the ghost. Save yourself from the ghost to, okay, so how many ghosts do we got? We got 4 different ghosts. Why I wrote 5? Because it's going to be like from 0 to 5 and it will gonna ignore 0 and 5 in the list. It's the rule of the list. Now the Pacman. Now the Pacman is in the coordinates of that vector. So our Pacman will gonna start from the coordinates of -40, comma, -80. Now, what does this mean? I'm going to let you know, and I'm going to make a ghosts different, and the ghosts are from the different vectors. So one of the ghosts is in the part of -180 to 160, and it will move towards the part of the vector from the vector of goal, that is 5 to 0. Now that's the vector of the goal from 5 to 0. It will move down towards that Pacman. Okay, now I'm going to copy for all these part for, okay, now this one, okay. 4 times. Now I'm going to put the vector change. It's going to be like minus 180. And again, now I'm going to change the coordinates from 0 to 5. The coordinates will be changed. Okay. Now again, I'm going to change the coordinates in this one. So I'm going to say 100 to 160, and the coordinates is going to be like 0 to minus 5. And the last one, the last goose will move up from 100 to minus 160. I'm going to do, see, the basic things, the basic rule. It's going to be like easy, like you can do the copy and paste a lot of code in this one. So these are our goose. Now the tiles, actually the dots. Now we are going to create tiles, which is going to be like TILES tiles. So it's going to be like, so I'm going to put 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Let's calculate it. It's going to be like 21. Let me calculate it. 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, let's have it. Again, calculate it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, now that's good. Okay, now here we go with the different tiles. Now change the tiles, but in the start and in the end, we just got 0 and 0, but in the middle, you need to change it. Okay, I'm going to make it copy for the 20 times as well. So I'm going to make a copy of it for 19 times. So it's going to be like 19 times. 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I guess that's more than enough. Okay, now we need to make changes in it. Now we need to make changes in it. How are we gonna do it? So first, leave first line as it is. Yeah, sure, Yasin, why not? Here you go. That's from where we started. So actually we are going to make the reflex agent. And for that part, we are going to make this small game for our reflex agent. Now, our hypothesis is, okay, sure. Now, our hypothesis is to make a different path that change the goal. So I'm going to change a little bit here. So I'm going to put 1, then again 1, 1, 1, 1, 1. It's up to you. How many ones do you need to have it? It's going to be your choice. I just leave this one, this 0. Again 1, 1, 1, and 1, and 1. Yes, I leave these 4 zeros as it is. So last 4 lines for the 0, and in between them you can have anything at any time. Like 1, I'm going to use 1, 1, 1, 0, 0. I'm going to put 1 here, 1 here, 1 here, 1 here, 1 here, 1 here. And also going to leave 2 of the lower one. Okay, now the next line. So I'm going to use from this one, again 1, 1, 1. Okay, let's make it 1, 1, 1, 1, 1, 1, 1, 1, 1. So this is how you're gonna change the whole parameter that we need to know. Left 2 as it is 0. Okay, now again this one, I'm gonna say 1, 0, 0, 0, 0, 4 times 0. Now put 1 here, then left 1, 0, 1. It's your choice how many 1, how many zeros you need to put on. It's up to you. Okay, now this parameter. Okay, let's change this one as well. This will gonna take a little bit time that you need to work it on. Okay, 1, 1, 1, 1, 0. Okay, 1, 0, 0, 1, 1, and 1. Okay, okay, let's make it work with this one. Okay, I'm going to change the whole parameter as well, but first I'm going to make the logic that we are here. So that 1 and 0 that going to be changed accordingly. So I'm going to make a function of scare because we are going to make we are SQUARE scare. We are in the scare function from X to Y. Now the reflex agent logic, the goal based. Yes, Yasin, definitely I'm going to. Actually, this is the box. This is a box in which our agent, the Pacman, is going to be the part of it. And this 0 is going to be like that boundary, and the 1 is that dot that our Pacman need to eat. That dot in this box, the Pacman need to eat, that is 0. And the 1 is that boundary in which these dots exist. So when these dots will gonna eat by our Pacman, this will disappear accordingly. So this is zeros and 1 here for the environment. So actually we are creating the environment that we are going to make it work on. Okay, now the formula, the scare, what we just do. So we make our Pacman to move up, right, and left. So it's going to be like path dot up. That's it. Path dot go to that axis that comes from the X and Y between the box. Now the path dot down. So our Pacman will move down, and the path from where the Pacman begins fell. So the Pacman will gonna eat every single white dots. So for that thing, I'm going to use for count how many dots do they got in that box. So start from 4. 4 will be the minimum dots in the path. Okay, so the path dot forward to 20 dots in a line, and then path dot left. So if our Pacman moves left, then automatically it calculates the 90 degrees. So it will move 90 degrees, and the path will gonna say path dot end fill. Why? Because our Pacman eat that specific dot. So whenever our Pacman is going to eat that specific dot, that dot will disappear, which means path end underscore fill. When the dot will disappear, it means this will be called. Okay, now the box in which our Pacman exists, in which our Pacman is in that specific box. Okay, now define offset of that specific point. What point? In the reflex agent, I'm going to ask my agent, my Pacman, so where you gonna start? So it's going to be like hypothesized this consequences action. So our action will be like up and down right now. So we don't have any other actions. So we have actions like up and down, nothing else. Okay, now up and down. So offset means, so we have some walls and floors. So it's going to be like x is equals to the boundary. So I'm going to say that boundary could be like floor for that one. So the point from which it starts is dot x. The x will be the boundary, and its size from is, as you see, it's going to be like 200, and it starts from the 20 dots as we already done, plus 200 again. Every time when it starts, it will come up with the 200 dots in that specific box with the division of 20. So it means every time when the 4 ghost will appear, so every time Pacman have 10 dots in the same line. Okay, now the same coordinates goes for the y. So floor dot, okay, let's make a change. Not, I'm going to change a little bit. So I'm going to let you know what I do. Okay, 180 degrees minus the floor that I used to above for the x point. So now the y point dot 20. It means whenever our ghost will gonna strike to our Pacman, the Pacman will disappear. Okay, now the Pacman will disappear, or the game will end. So actually not disappear, the game will gonna end. So it's gonna be like x plus y times 20. Why I'm going to use times again and again and again and again with 20? Because I'm working in the specific box in which we have 4 ghosts and our Pacman trapped in that specific same box. Now I'm going to say the validation point. If you're gonna memorize all that specific code as it is, automatically you will know about the reflex agent. Agent means in AI, I'm going to show you a little bit of the agent stuff, how it works. So I'm going to stop here. Now I'm going to explain what I just did. Then I'm going to move forward. Till then, we have a screen. We always have a screen. So consider it like you have your desktop. This will be your desktop. Okay, in that specific desktop, you have boundaries. You have different boundaries. Like the boundary starts from here to this one, not the collision one. Now this is your boundary, and then you have floors different. It's going to be like this way, and it is interconnected with each other. Each and every floor is interconnected with each other. Every time it's connected to every floor, but it will not gonna collide with that specific environment that is in yellow. Now we have vectors. That is the ghost we choose to work it on. So our ghost is in the pinkish form, and these are our ghosts in that box. 4 vectors. With the help of random choice, we made this interface. We have this interface. With the help of turtle, we made this yellow box in it, and we have our yellow box. With the help of floor, we made this specific white box. With the help of floor, sorry, the red boxes, we made these specific red boxes. With the help of floor, we made these boxes, these red boxes, and with the help of this vector, which is under the, I'm going to use the eraser, and so with the help of this vector, we made these ghosts. Now, state, the space, the whole space that we are working in, the whole space that we are working in, that is state, is it's also called the state space. So we are in the state space in which we are working on path, turtle. So we don't have anything right now in this box. So we say we have a path. Yes, we have different paths. So we don't have anything in the path. Yes, it's false. So we don't have any Pacman who is eating the ghost. Yes, false. It's going to be good. Now the goal is to have 5 vectors, including that ghost. So the ghost will be our fifth vector. The Pacman will be our 5th vector. So we have 4 ghosts and the 5th Pacman. So we have 5 vectors. That goal is the 5th vector is going to eat every single dot in that specific environment. Okay, now the Pacman vector could be in somewhere with the coordinates of this one. So Pacman would be somewhere with this coordinate. So I guess it's going to be like from here or maybe from here. So it depends with the coordinates. So our Pacman, so from where our Pacman will gonna start. So this gonna be our Pacman. This is gonna be our Pacman, and these are our ghosts. These all are our ghosts with the different coordinates, combination of different coordinates. With all this thing, what we just make the things that we are working on. Now on the downside, on this downside, now this is that interface of the part in which we have dots, in which we got these dots that will be eaten by our Pacman. So these will be the dots. So 0 will be this boundary and the one will be that specific dot that need to be eaten by our Pacman. This is how we made the whole environment. Now, with the help of this environment, we made a function in which the scare function in which we have the dealing. Now, this is our scare function, which actually means scare means the box that we already have. So our Pacman will go up, down, and go around in with the go to statement and begin with fill. So what happens? It means this box will gonna divide on the back end with 4 different coordinates. And every coordinate have their own functions. Every coordinate is gonna have their own functions, different functions that need to be followed by the rules. So whenever our Pacman will go up and down, right, up, down, right, left, every time it will be count with this statement. And when our Pacman eat anything, when our Pacman is going to eat any dot, this will gonna count the dot and that dot will disappear. So whenever the whole process is going on, whenever the whole process is going on, this for loop will gonna help us to make it work accordingly. This for loop will gonna help us in that way accordingly. This coordinate will gonna help us in that way. So the basic environment we just make through which we are going to make it work. Now this scare we're gonna help to count in the box, and this will gonna count how many ghosts and the orange dot or actually white dots we have in the box. Now I'm going to validate that the above information do we have is accurate or not, because what we are dealing in, we're actually dealing in this environment, the Pacman. So I'm going to calculate every information that we got in this part that is correct or not. So I'm going to calculate it down here. Okay, now index we have, the code we have, and then the validation. So with the help of this index offset, now if my tile, the tile means the red one, the tiles. So if TIT, TILES, tiles, if tiles, the above I mentioned, index equals to 0, means when our dot will be disappeared, the tile will remain same on the position and it will say return false because the dot will disappear, not that specific tile. So index will remove that specific dot from that point and will count into the minus part. As I told you that we have 20 dots in same line, and when one will disappear, how many left? 19. Then again, we are going to repeat the same process. If tiles index will gonna equals to once again 0, what will happen? It happens again, return false. And now the interesting thing, what if this will do again and again and you have left with the 0 dot, then you can easily return, when you left with the 0 dot, return that specific point dot on the x-axis modulus of how many dots we have in the start. We have 20, so all will be gone or eaten by the Pacman. So we don't have any dot left on x-axis or in y-axis. We don't left any of it. So this is how we're gonna make return. Now, we don't have anything right now. Now I'm going to create the whole environment, the world. Actually, I'm going to talk about this one right now. So the tiles that we used to call in red. So when we don't have anything in the tile, so it's going to be like 0. Now I'm going to create a world again. That is going to be like a defined world and background color. So what kind of background color do we got? We usually got the black. And the path color is also going to be path color. It's going to be like blue. It's going to be like blue. Okay. Now, whenever our Pacman will gonna eat, from that specific part. So for index in range of that tile which was eaten by our Pacman, if that's in our range, then the tile will be disappear from that specific index. That's how actually Pacman eat things, and this is how we can create a logic. If tile, so I'm going to make it work with the tile as well. So if tile is greater than 0 right now, then x-axis means, so on x we have something to be eaten by our Pacman. So we have 20 tiles times 20 minus 200, so it's going to be like 0. So we can put 0 as well. Okay, now y is equals to, again, the same step we had done before. Index divided by 20 times 20 again. So it's going to be like 1. Now what we call is SQU, SQU square of what? Square of x and y. Okay, I'm going to call it a function, so square of x comma y. So we create this environment with respect to x coordinate and y coordinate. X for right and left, y for up and down. Okay, now what happened? If our ghost will strike to us, then tile is going to be equals to 1 because the tile will left, b or ghost up not. So the path is going to set, you can move up, or your path will go like, you can go with the go to statement with the coordinates of x, plus you can put 10 step ahead, you can put 100 step ahead, you can put 50 step ahead, it's up to you. So I'm going to put 10 step ahead on from the x-axis and the y-axis. Why? Because I need to secure at the second time that my coordinates will go in a different way. Now the dots, two spaces, actually the dot 2 means the 2 spaces, and the dot will appear in a white color. You can use pink, you can use any color that you need, that you like actually. Now the movement of the ghost as well as the Pacman. Now if you're gonna press up key, the Pacman will go up and goose will move automatically. So first we are going to write the writers for the Pacman. So whenever you're gonna say move up and down, so it's gonna do the undo statement, because every time when you press the key up, after it will clear the move because it's moving up. So I'm going to say the writer dot write, as I say, the state, S-T-A-T-E, state of what? When it moves, when it eats, it will increase in score. And if, as I said, clear the number of steps, that already done with this move. If our step will be validate, V-A-L-I-D, valid, so our Pacman will move towards goal. And the Pacman the Pacman dot move will gonna towards goal, G-O-A-L, goal, will move towards that specific goal. Why it's not picking up? V-A-L-I-D, V-A-L-I-D, valid, V-A-L-I-D. If the valid Pacman, it's a good function. Okay, let's see why it's not picking up. Okay, then index of that specific file, it's going to be like offset of that one. Offset of what? Offset of Pacman. And if tiles again for the Gooster right now. So I'm going to make the tiles for each and every movement for 1, 2, and so on. So I'm going to make a movement for every tiles. So tiles, again, the index that we need to count equals to 1, and tiles again, index equals to 2, and the state, S-T-A-T, state of score, S-C-O-R-E, score, that is plus equals to 1. And now again the x-axis, because whenever you design anything, whenever you design logic, whenever you design game, whenever you design anything, it comes with the logic, the index, because sometimes I don't even, to be honest, sometimes I don't even remember what logic that I'm making on or working on, especially in the part of games. Sometimes it create a huge problem, and sometimes it's not, but sometimes only. Okay, now the state, the game, and okay, now minus 200 again. So a lot of steps that we use to copy again and again, and we need then work accordingly. So index divided by 20, and that times 20 again. I'm going to let you know actually what's going on, and that's an easy way. That's the easiest part, that I'm having there with x and y. And this is what I called up. That's how our Pacman move up and go to that specific part of the Pacman where he wants to move. Pacman dot x time plus 10 comma Pacman dot y plus 10. So what we just do, actually what we just done, so I make the dots that will be eaten by the Pacman. The Pacman is in yellow. Yes. The Pacman is in yellow. Okay, few more lines and we are done with the agent. Actually, what just happened? This is the environment. This was the environment I was talking about. Two dashes, index. Where I put two dashes, slash. Okay, slashes. Slashes means division. Slashes mean division. It means division. We can use single division as well. While in making an agent, we used to quote actually double dashes. Actually, what is going on? This is the environment we are working on. This is actually agent in AI. Artificial intelligence, that was actually uh, the 2014 based algorithm. That's agent. Agent means while working in anything, artificial intelligence will be involved in any of it. Perceive an act and has a goal. Let's take you a simple example. Then I guess you will gonna understand in an easy way. Okay, now this is a reflex environment and a game we are going to build, and I guess within 10 minutes we are going to complete it in proper way. So what is going to happen with an AI? What is going to be happen to your system? So let's take a simple example. You need to buy something. You need to buy cell phone, or make it more clear. You need to buy iPhone 11 Max Pro. So what you should do, you go to the market and get that cell phone. So it's going to be like 3 cameras in it. Okay, it's going to be like a different camera. Okay, and like this is your iPhone 11 Max Pro. Or how much investment do you need to get this one? So you need actually 2,100 pounds, if I'm not wrong. Okay, so you need actually 2,500 pounds. So this investment you need, this investment you got, what if you get an agent to buy this cell phone? While on the market, you tell your agent that you have the investment of 1,900 pounds. 1,900 pounds. So you told your agent that you have the investment of 1,900 pounds. So agent knows your goal, that how much investment do you have, that is 1,900 pounds. But he will not gonna happen, he will not gonna help you within the 1,900 pounds. Why? Because it's an agent. So he will create an environment through which you can pay 2,100 pounds. So this is how the agent deal in AI. Agent knows your goal. He knows that where you want to be, like a Pacman. So every ghost know the Pacman is going to eat every of that dot given in this environment, given in this specific environment, every of the single dot. But what the ghost will do, the ghost will gonna stop this Pacman to eat all of these dots. To eat all of these dots, the goose will gonna stop them. So actually, we have a problem of space that we usually call the state space in AI, and that actually work in this Pacman. So we just created this specific environment for this Pacman through which We have tiles, we have ghosts, and we have that white dots. Now we are going to set the rules through which our Pacman will going to eat. Now the rules of our Pacman and the ghost as well. So for gaining the points, for the points, so for point, course in ghost, GOHCS ghosts, which if valid, VALID, wait, not, it's going to be like valid. Do I put the wait over there somewhere? Because if it's showing me the weight, it means I put somewhere the weight. I don't even put the weight over it. Uh-oh. VALID valid. Okay. Okay, if the validity, if valid, now the point, the valid point plus course through which we have our Pacman in it, then move our Pacman will gonna move towards that course, and what happened? And definitely if he will eat or not. If he'll not gonna eat anything, then else what happens? So we're going to put some options. Either one of the vector going to eat, strike that one. So I'm going to say the vector 5, 0. I'm going to make it work with we have 4 ghosts. Okay, comma, 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 and comma. Now the specific directions we just got up. Okay, -5, then 0 to 5, and we're going to put 0. Okay, 0 to -5. Now these are our 4 ghosts which we just created above, and then plan the head plan, PLAN plan, because agent always plan ahead. So our agent will gonna plan twice some option we just got, then it changes the course in X. It can change the X, so we have a plan X, plan.x. If it's going to change the course, COURSE course dot in Y, then we have plan.y. It's going to like up and down, left and right. So it's going to be for the up, as I said, up and down, go to, again the same thing, the point.x. Most of the thing in this part, in the part of the reflex agent, we're going to repeat again and again because we are working on the same environment. And the dot we're gonna do with the 20, and the ghost is in the red color. And we are going to say update the path because he ate the white dots. Okay. Now 4 points, POINT, 4 point, comma, course in ghosts. Then what happened? If absolute value gonna find for the Pacman, ABS stands for absolute value minus points where the Pacman exists is less than 20, then return towards that point, and on timer we're gonna stop, move up to 100, from 200. Okay, now the last function, define change the coordinates of x and y while moving in the while Pacman is moving if valid statement of Pacman plus vector will move in the same coordinates of x and y, then definitely the goal dot x is equals to x when it's going to eat everything, then goal dot y equals to y. It will change everything. Now the setup of that specific screen. So setup is going to be like 420 dot 420 370 0. Why it's not calling up the setup? It's going to call the setup. Why it's not calling the setup? Okay. Okay, let's see what will gonna happen if we don't have a setup. Okay, iterl. Okay, then tracer, we're gonna got false because we don't need any kind of tracer. Then writer dot ghosts, writer dot go to that specific equation is going to be like 160 comma 160. I'm afraid that why setup is not calling. Okay, let's see. Then writer dot color of that specific dots are in white color. So dot would be in white color. So writer dot write. So I'm going to let the computer know about the state, course, score, and listen. This is the built-in function listen. Okay, now the listen, he's going to listen on key. On key, when the key will gonna press, it's gonna say on key lambda, and that's gonna call the specific change of that key from the vector. If the vector is from the position of 5, 0, then it will move right, although you are going to have the control of the keys as well. It's just for the movement, that if it's gonna find anything in front of it and how it's gonna survive with this functionality. So it's going to be like 0 and -5, right, and it's gonna be like left, up, and down. World, move, and done. That's it. So this is how we're gonna create a reflex agent game with the help of an AI. So we use the different rules in which we create set of states, successor function, and the goal. So goal is to eat all the dots from that specific space. So let's make it run. Okay. See, we just made the coordinates actually working in this specific environment. So this is how it appear. The white dots, this is our score from starts from 0. It stops because we don't create the whole environment, because I just stopped myself for creating the whole environment in that part. This is the environment that we need to create. So this is the basic interface of our Pacman game, through the point of an AI. So automatically our agent will gonna learn things from this part. Automatically it learns. See, first we got just one ghost, now we got 3. It automatically start learning, because again the 3, again let's see how many do we got right now. Again 3, but every time it moves ahead, every time it moves ahead. And if you see very carefully, okay, now this will disappear. And if you see the very carefully in this box, we have another box, as I told you that I'm going to make. So inside that box, we have another box. And inside that box, we have these tiles. So our agent will know where is our Pacman is, where our Pacman is. So actually, if I made the complete board, this will gonna make it work in every part, because the 0 and the other board will gonna work accordingly with the part of it. So actually what we just did, we just make a problem solving state in this reflex agent. So AI actually is in all over the system, is in all over the way, is in all over the things. So let me explain a little more about this AI. Actually, there is a state space in which our Pacman is going to eat. The successor function is, these are those coordinates. So with the help of this successor function, we made our coordinates as well in X and Y. Yes, these are coordinates. These are our coordinates. These are our coordinates, which is shown in this figure. So I made our own coordinates through which we can have the successor function, through which our Pacman is going to eat everything that he needs to eat, the white dot section. Now the start state is where our Pacman starts, and the goal set test is through the whole state of white dots, our Pacman is going to eat everything. Our Pacman is going to eat every single white dot. Every single white dot. Okay, let me change. Okay, let's copy that specific environment here. Why it's not copying? Okay, paste. Yes, now this is our board, complete board. I make it save. Okay, let's complete the packages processing. Okay, now it's completing. Now make it run. Let's see what will happen now. See, now this is our Pacman. It will moving up and down, but it's not eating anything. It's not eating anything, but it will move up and down. So I'm going to make it work to eat the things. So when it strike towards a ghost, what happened? Yes, the game stops. Okay, now 90% is working correctly, but it's not eating the dots. So let's see what happened inside of it. Why it's not eating the dots? where I just put the mistake for eating the dots. Move up the red one. Everything is okay. The setup actually is not working. Unsolved setup. That's why it's not eating the dots. Why I need to import all the setup. We have choices, we have floors, we have everything that we need to work it on. So what happens to dots? I just put some minus somewhere, I guess, through which it's not eating the dots. So where I put minus. So our environment is good. The working is good. Everything is good. Degrees 20, 27. Everything is going good. So where I just put a mistake. Why it's not eating the dots? This is a logic through which it will gonna return 0. Dots will be in blue, that's good. And it's look good. Indexing 180 minus every index. And that's gonna happen with the dots scare, okay. Tile goes to 1, move up, down.
In y-axis after index you put double slashes.
Yes,
Why?
it's for the division. It's for the
Okay.
division that we
Okay.
need to use, because in the specific agent environment, we need to divide one agent on two sides, like in this picture. So it will go north or it will go east. So we don't know where it's gonna start from, the left side or the right side. So we put two dashes. So whatever the choice of the user is, while we are pressing the up and down key, it will move automatically towards that specific direction in which we are going to move. So that's why we put two dashes for the division part.
Okay.
Here I put the mistake, I guess. Here is the mistake I made, I guess. The title that I used to make, okay, the world. Inside this world, up and down, right and left, okay, the movement. Seems everything is good, like, but why not it eats? Why not it start eating? It's clear everything when it's show to the move, it will go towards the goal, which we already have, yes. Index for the offset of the Pacman, yes, it's going good. With 2, 1, minus 200, yes, minus into 20, move up, go to the Pacman, go to that specific index, go to that ghosts. Every time that ghost, check the validity of that one, move towards that one, minus 5, 5 minus, okay, that's good. Plan the choices, plan.x option, move up, go to that one.
Here I think maybe in vector there are -5, -0 because you are not putting this option. 50 minus 50 05 or 0 minor, but you are not putting -5 -0 maybe.
No, we don't even need a -0 because 0 is already in that part. These are the vectors through which, when it strikes to any of the vector, our Pacman will die. So this is actually the vector
Then there is
position.
a very small logical mistake in the program, I think.
Yes. Through which that's why they can't eat the points. I guess not logical. It's somewhere I put minus, or somewhere I guess I put wrong addition. Okay, that's why I'm checking. Plus vector x and y, the Pacman goes to the valid point. It's going to set to an xy. Setup, okay, setup is not just for the time. It's going to be like 160, 160. That's good. White in color. Score. I'm gonna listen to that lambda. Lambda means to strike with up and down, world, move and down. It's totally good. It's totally, we don't put any mistake. Wait a second here. In the movement of tiles, while moving, score will go up. Yes, score will go up. Oh yes, that's a mistake. A little bracket done a lot of things. See, that little bracket done a lot of things. Now, the Pacman is eating white dots. As I'm moving with it, it's eating every single white dot from this specific environment. So this is how a reflex agent is working. So if you see the movement of every ghost, it will come towards that yellow. But whenever I'm going to change the position, it changes its position as well. So that vector red learning from my path. That's how actually the game works. This is how the way the game actually works. See the red one, it's actually this red one following the move that I'm making again and again. So I scored like 94. So this is how this Pacman game work in the environment of reflex agent. So this is also an AI, a simplest AI that I use to build a lot of things on this kind of simplest AI. So this is an environment. This is a whole environment. If you just put this specific code in and you work on this specific code, then you can easily solve any of the logic, any of the code, you can make any of the code, you can even solve anything logically. So that's how AI starts in games. So again, we have a lot of things like n queens. Okay, let's put you on a logical assignment. Let's see how you're gonna solve it. There are four queens in this box. Okay, let's make it like a more interesting way. Now these are the 64 boxes. Okay, let's make it 1, 2, 3, 4, 5, 6, 7, and 8. One. It's already one. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, now we got 8 lines here. 1, 2, 3, 4, 5, 6, and 7, 8. Now we have 64 boxes. Now this is more interesting. Now I'm not going to put n number of coins in that box. So how are you gonna solve that specific thing, that specific one, if you need to add 8 coins in that box? How are you gonna arrange them that they can't cancel each other's effect? It's a rule of a chess, that how you're gonna make it solve. These are the 8 queens that you need to put in this box in that way that they can't cancel each other. They can't even bypass each other. Oh, wow, I put 7 and that's 8. Oh, not that way. This one is. Now in these 64 boxes, I arrange 8 number of queens. Now I just need to know what is the logic behind and how we're gonna solve 8 queen problem in 64 boxes. Let me show you how we're gonna solve the 4 queen problem. Each and every queen is arranged in this box in that pattern that they can't cancel each other. They can't even bypass each other. So what happens? It's like this way. If so q queen dot path is greater than 1 2 3 4, so it will count. So the queen is in third index, so more specifically q dot index is greater than 4 or equals to 4, then print, you can say print queen is okay. The queen's fine. If the index is greater than or the smaller than, if q dot index is smaller than 4, count plus equals to 1 and then print. So this is the simplest logic for 4 number of queens, and it's going to be happen with 8 as well. So what if we got n number of queens? So what will be the logic? It's not going to be the same one. It's not going to be the same logic we're going to put on n number of queens in n number of boxes. So your task is to solve the simplest equation, like how we gonna solve 8 number of queens in 64 boxes. 8 number of queens in 64 boxes. You can even find the help over the internet as well. Like you just need to search like this way. N queen problem in artificial intelligence, simple. And you will gonna find help, a lot of help over the internet as well. But I need you to find that specific logic, that how you're gonna solve n number of queens with the help of an AI. How you're gonna solve n number of queens with the help of a lot of things. So these are actually the problem of agent-based working that we just had done. So that's how you're gonna start working in games and a lot of things. So this is actually the problem of state space we just had made done. The problem of state space through which we made the Pacman with the states of x and y dot, which is actually the Boolean function, and each and every states count in x and y, and the path will lead us towards our goal. So this is how we're gonna make working in AI. Now, I'm going to send you the source code as well of this part and the video in just 30 minutes after processing it. Then after it, you're gonna start working over it. You have to memorize the code. You have to make it work. And in that part of the code, you will find another task, which will be the simplest one. And that will help you down in freelancing environment as well. through which you can have 250 pounds for making an algorithm, because I just got a queue from the Upwork from my profile in which I have to make a simplest algorithm in the same environment, the agent reflex agent environment, through which I can have 250 pounds for it. So that's all for today's class, in which I guess this is one of the simplest class, not the hardest class, I guess. One of the simplest class in which we just made a simple code, simple steps, and the simple environment. Yes, sir, definitely I'm going to share each and everything. And here is a code. I'm going to send you the code right in the chat box right away, so you can have the code and the things that you need to know. That's a part of the code. Okay, now we just need to find that specific code. So I'm going to downloads where I find that's it for today's part. I hope that this will be the easiest. This is the easiest one that you got from the previous lectures. So if you have any query, then do let me know over my email, and I'm going to reply, and I'm definitely going to reply the email in just 10 minutes. So if you have any question, then do ask. Miss Sari, do you have any question?
No, thank you, please.
Okay. Miss Fatma, do you have any? Okay. What about you, Umar? Do you have any question?
Dr. Sab is fine. I think today's lecture is more comprehensive and simpler, and also it is up to the mark.
Yes, definitely. What about you, Yasin? Yasin, do you have any question right now?
Well, this lesson was very easier than the previous ones.
Yes, Miss Fatma, you want to say something?
No, it's okay. It's interesting.
Because it's the simplest one.
Yeah, it's simplest.
Dr. Sab, students look like not very comfortable because they think the programming is difficult, but I told them programming is not difficult, but the reward could be more for
Yes,
this programming.
definitely. Definitely, sir, it is. It is. As you see, like we just make a code from this Pacman. This Pacman, the agent, we just make an example from the Pacman, and we just made it happen properly, working over how.
I know they are not happy with me as well.
So it's a part of our life, as we discussed before, that the life is always about the difficulties that we need to tackle. The code is not that difficult, but the logic that we need to make for that working.
It's just the understanding. Sarish, Fatma is here, Yasin is here. And trust me, I have seen the people, they have a very, very bad experience in the study, in the class. They are the backbenchers, but they click the programming and now they are the best
So
in the programming.
Yes, sir. And one of the biggest example that we have, the CEO of the Google.
Yeah.
He used to be the electrical engineer, and right now he's the expert in coding.
So I can understand that it doesn't look that simple, which I agree with you guys. But I think if you take as a simple step, go one by one, draw the small program. For example, you draw the program, how many people living in the house? One program. Then you can say second phase, let me learn about how many male and female in your house. Second program. Then you learn about the ages of the, how to find the ages of the male, female, and infant. Third program. Then you can say how many utilities in your house. Fourth program. So you can start to learn this small, start from your house and find out how to find the street address